let's see if your prediction was right. Copper has a much smaller heat capacity, and what that means is it only takes 0.386 joules of energy to cause the temperature to go up by 1 degree Celsius. So it takes less energy to raise the temperature of copper than it does aluminum. Aluminum takes a lot more energy, almost 3 times as much energy. It takes 0.9 joules of energy to lift the temperature of aluminum by 1 degree Celsius. So since it takes more heat to increase its temperature, I think this one is going to increase its temperature less. It's going to have a smaller change in temperature. And this would have a larger change in temperature. Now I'm about to hit play on this, and we're going to see what's going to happen here and see if it turned out that my prediction was right. Because some of you might be thinking, hold on here, didn't we forget something else? It's not just the heat capacity that matters. So let's see what happens. See if my prediction turns out to be true. It's going to time lapse it here soon, so we'll let it speed up. Now already I'm getting a little bit worried about my prediction, because it sure does seem like the aluminum on the right, which I thought would have a smaller change in temperature, seems to be getting hotter faster. We'll see if that holds up. Yeah, it does seem to be holding up. They're actually fairly close, but for sure the aluminum's changing temperature quicker. So what's going on here? Why is it that our prediction did not turn out to be true? Well, it has to do with the mass. It's not just the specific heat. If you said, hold on here, I need to actually know the mass of these things. Let me go back to where we can see the mass of both of them. The mass matters as well. Even though it takes less heat to increase the temperature of copper by 1 degree Celsius, it's really actually kind of hard to see in this image. Maybe if I go forward just a little bit. There we go. That's better. Look at how many grams. There's 93.2 grams of copper. There's so much more copper. There's only 29.6 grams of aluminum. So there's way more atoms of copper in here. Now, if we had had the same mass of both of these, then yes, my prediction would have turned out to be true, that it takes less heat for copper to go up in temperature. But I wasn't taking into account that there's just a lot more copper atoms. So remember that our equation was not just about change in temperature and heat capacity, right? We were using this as our tool to predict the change, but the mass matters as well. And so we need to take both into account. Now you might wonder, was I intending to be this tricky? No, it's just what I brought home when we left school were these two samples, and they are not the same mass. So even though we can use the specific heat to predict the biggest change, we've got to take into account the mass as well.